And while you're doing that, I'm going to be handing back a couple of things. Some folks have not gotten their Concept Quiz 7 back yet. I'm going to be handing back your Concept Quiz 7, those that haven't seen it yet. And at the same time, I'm going to be handing you your retake assignment. So this will just be for folks that need or want to do a retry on this. I've just printed out the retake assignment for you. And then I don't think hardly anyone's seen Concept Quiz 8 because that's the one you just took. I'll be handing that back as well as a redemption assignment for Quiz 8. Okay? Fair enough? So you guys can be working on that DMR. And I will be. So I apologize for my childlike writing here, but I had to use my finger because my pen is about dead. So here you go. Please forgive the penmanship. It might be better than when I usually write with a pen. I don't know. That's not that great. So number 1, I got x is equal to 28 ninths. Number 2, I got y equals 2x plus 11. 3, I listed all my x coordinates for my domain and my y coordinates for my range. Notice I only listed the 5 one time. Of course, there was 3 5s, but 5 is just 5, so you really don't have to list it once. And then, is that a function for number 4 there? The answer is yes, because each input has exactly one output. It's true that some of the outputs are the same output, right? But every input has exactly one output, making it a function. So I would absolutely love to answer any questions you have. How did you get number 2? How did I get number 2? Why don't I see if my pen works now? See what happens here. So, what are the 2 things you got to have to write the equation or the graph of a line?
The point on the line.
Point on the line and slope. And right now, wouldn't it be fair to say that I have 2 different points that are on the line? So essentially I do have my point on the line. I've got 2 of them. What I don't have is my slope. And so I got to think, how do I take 2 points and figure out the slope? That is that idea that we talked about in the past. Slope is the same as rise over run. And rise would be the second y coordinate minus the first y coordinate divided by the second x minus the first x. And so to find my slope, what I would do is I would say that my second y is 15. Does that make sense? Okay. In fact, I'll tell you what. Why don't I try to color code this? So 15. What is my first y? 5. And then if you're trying to find the difference between 2 things, what do? You subtract. That's right. So I'm going to subtract those. And then what's my second x? 2 is my second x. That's going to be highlighted in red. And so I got 2. And what is my first x? -3. So that's right, that's exactly what's going to happen. So there's that. And my -3. And again, this is where people will tend to lose minus signs. If they're going to miss them, they're going to lose them. This is where it's going to happen. We do need to subtract those x coordinates in order to find the run or the change in the x's. And so Bray was right when he said it's really plus. So I get 15 minus 5 over 2 plus 3. So that's 10 divided by 5. And that's where I got my slope of 2. Making sense? Okay. So again, let's review. If you're trying to write the graph or the equation of any line, what are the 2 things you got to have?
The point and the slope.
And I just figured out the slope. And don't I have 2 points, actually, that are on the line? Does it matter which point that I use? Should I use the blue and orange, or should I use the red purple? It doesn't matter. You can pick either of the 2 points. You must be consistent. You can't pick if going by color here, you can't pick blue and purple, because blue and purple are not part of the same point. You can't pick orange and red, because they're not part of the same point. You have to go blue-orange or red-purple. And I'm going to use point-slope form, right? Because I've got a point and I've got a slope. So point-slope form is actually written on the board behind me, but I'll write it again because it's so awesome. That is point-slope form right there. Y minus a y coordinate equals slope times x minus an x coordinate. So, Sophia, you asked about this one. Which point would you want to pick?
32 and 15.
Sure, that's the one I think I picked. So what I would do here is I would write y minus the y coordinate. So I got y minus 15 equals slope, which is 2, parentheses, x minus an x coordinate, and that of course would have to be 2 because you picked that point. That is point slope form, and that is a perfectly fine form, except it said that it wanted it in slope intercept form. So I now just need to take this and turn it into slope intercept form. What do you guys think would be a good first step on trying to take that and put it into slope intercept form? Okay, you could add 15. So this would give you y equals 2 parentheses x minus 2 plus 15. Now that we've done that, what do we have to do next? Got to do a distributive property. You could have done the distributive property as a first step. Either way is going to be fine as long as you navigate that well. So it'd be y equals 2x minus 4 plus 15. And then my final step would just be to add those two like terms on the end. Negative 4 plus 15 is 11. So y equals 2x plus 11. So what do you think? Is that okay? Awesome. Other questions or maybe a follow-up on that one? I'd love to answer for you. Thanks for asking, Sophia. Other folks? Number one, I didn't show you any steps at all. Oh, Noah, yes? Oh, sure. I was going to ask this question of anyone. Noah, you can answer this if you want. When you look at this equation, and you look at the left side of the equal sign, that whole left side obviously a lot more complicated than the right side. What procedure, what property, what thing do you see? What concept do you see on that left side? You got to do that. I really think before you solve, you want to try to simplify, and the distributive property is a pretty nice way to simplify. So I will do what Noah just said and distribute. So 3 times negative 2 is negative 6. What is 3 times 3 halves? It's 9 over 2, right? Because it's technically 3 over 1 times 3 over 2. So it'd be plus 9 over 2x equals 8. So what's when you see the word solve, what is it really asking you to do? What's the concept? What's the... Find what x is, right? And we do that by getting the x isolated by itself, right? And obviously you can see on the left side of that blue equals fence, it's not by itself. What do you guys think would be the better move? Should I try to get rid of the negative 6 or the 9 over 2 first? Like, which one should I try to handle first? The negative 6 is definitely the one to make it easier. You could do either way, but it's easier to do the negative 6. How do I get rid of just a negative 6 being added to the x? Yeah, you add a positive 6. Right, so I'll go plus 6 and plus 6. That'll give me my equation to be 9 over 2x equals 8 plus 6 is 14. So far, so good? Okay. Noah, do you have any idea, any thoughts on how I could deal with that 9 over 2? You could do it in 2 steps or 1 step.
You could divide it by x because it's being multiplied.
Ooh, careful. If I'm trying to solve for x, like I'm trying to get the x by itself, I should never multiply by x. I should never divide by x.
Divide 9 seconds by...
Oh, divide by 9 over 2?
Yeah.
That would work. That would work. So if I divide this side by 9 over 2, of course I've got to do the exact same thing to that side. Wouldn't that mean that 9 over 2 divided by 9 over 2 is just a 1? It would cancel out to just give me an x over there. On the right side, if I take something, like in this case a 14, if you divide by a fraction, what's that little procedure we learned on how to divide by a fraction? Copy, dot, flop, right? So this would be 14, flip, flop. Okay, flippity, floppity, times, right? So Noah, 14 is your copy. Dot is the changing of division and multiplication. And the flippity, floppity, whatever, that's the reciprocal of 9 over 2. So times 2 over 9. That's really 14 over 1. 14 times 2 is 28, 1 times 9 is 9, and there's your answer. Does that work okay? Okay. Okay, so there is, this week, no concept quiz, I don't believe. Actually, I'm for sure, there's no concept quiz this week. Your only big grade will be Friday's DMR, which of course will be this. So if you want to have a nice week as far as new grades go, man, let's bear down and really focus this week on this DMR. Looking at this, watching your reactions, I feel like this could be one of those DMRs where everybody makes 4s and 3s out of 4. I really believe that. But I also believe that will not happen if you just sit there and say, well, gee, Mr. Anderson, I don't know what I'm doing on 3 of the 4, and I just won't try. I just won't ask. I won't try. I won't be engaged. You'll do poorly, right? I mean, that's just how this goes. So I hope that you will be engaged. Great.
I have a question on number 4.
Absolutely. Let's do it.
So it says each input has exactly one output.
Right.
We said every input only has one output. Is that the same thing?
Yeah, I think that's good wording. Yeah, for sure. I think you're questioning the wording is good because it's easy to just work in something that's false that sort of sounds okay. I think what you said is fine.
Okay.
Yep.
Cool.
That's good. Anybody else? Maybe a question like that, I wrote something a little different. Seems okay. Is it really okay? Okay. So I have a question for you. Some of you might have already thought about this. Others might not have thought about this. In a year or two, you all will be drivers, right? Anybody super excited about being a driver? I was. I'll tell you, man. When I was 9th grade, I'm I can't wait to be able to drive a car. Anybody just super indifferent, take it or leave it, I just don't care? Okay. Anybody absolutely does not want to get a driver's license?
What?
Why? I want to get my driver's license so bad.
Okay.
I want to get it before you.
It's okay. It's okay. So whether you're like Isa, who's I would rather avoid driving, to Bray, who's I wish I could have been driving 4 years ago, or somewhere in between, I think what we're going to be focusing on throughout this unit might be of importance to you, because as much as Isa might not want to drive a car, odds are pretty good she at some point or another is going to have to drive a car, and later on as an adult she might actually have to buy a car, right?
Wait, why don't you want your license?
I just don't like the road at all.
Fair enough.
You don't like the road?
All the scary stuff on the road. Yeah.
Oh, my bad.
So, guys, listen up. What I want you to think about is this. Our kind of culminating project here in Algebra 1 for our Unit 3 is going to address this question I'm about to ask you. And you might think, is this a big deal, is this not? But I want you to really think about this. One of the more popular varieties of cars out there these days is a hybrid. Of course, there's full electric, and there's just regular gasoline, and then the hybrid is the in-between, right? And there are a lot of cars that advertise themselves as hybrid, and they're supposed to be good for a wide variety of reasons. But one of the questions we're going to try to answer, and it's going to be through our project, this unit, is going to be the question of, is a hybrid car really worth it? And you might have just a quick answer of no, it's not, or absolutely, yes, it is. Or you might be kind of I don't know, what even is a hybrid? One of the things you're going to learn this unit is, A, what is a hybrid? And B, based on certain circumstances, do you think it's worth it, or do you think it's not to get a hybrid? Is it the better purchase, or is it not the better purchase? And so in order for us to be able to answer a question like that, we're going to have to develop a couple of skills. And that's what the next several weeks is going to be about, is developing those skills. And then a little bit before Thanksgiving, we will be doing a little research project on hybrids and gasoline-powered vehicles. And if you don't already know what those are, you'll learn a lot about them. And if you already do know what those are, you're going to learn to get even further into the details about, hey, is it worth it, is it not worth it, that kind of thing. But before we can really answer that question, you need to have certain skills. And so that's what we're going to be working on these next couple of weeks. That make sense? All right. So if you would, flip over to our first page here in our Unit 3. And I'm going to introduce what for some of you might be a brand new term, and that is a system of linear equations. You really can't answer the question. You guys should be on the next page right there. You really can't answer the question of should I buy a hybrid or gas-powered vehicle, and many other questions for that matter, unless you understand how to deal with what's called a system of equations. And specifically for us, it's going to be a system of linear equations. So what is this? I want to explain what this is. A system of linear equations is more than one equation, more than one linear equation, I guess I could say, graphed together. Graphed on the same xy axis system. So more than one linear equation graphed on the same xy axis system. So for us, we're going to focus on systems that contain two linear equations for the most part. Other courses, you could have 3 or 4 or 5 or 10 or 20. And there's other techniques on how you deal with some of those things. We're going to focus on just a handful of those techniques. All right, so here is a big takeaway. So I'm just thinking about you guys in 23 minutes as you're walking out of the classroom. If you could have this takeaway, this would be awesome, okay? So this would be a big takeaway from our class, this next statement. The solution to a system of equations is the blank blank that is a solution to both equations. Here it is. Fill in the blank for you. The intersection point, and that is a solution to both equations. So the solution to a system is the intersection point. And what does intersection mean?
It's like
It's where they cross. Say again?
four-way stop.
A four-way stop. Isn't that where the roads cross?
Yeah.
It's where the lines cross, right? It's the same word, right? An intersection on the road is the same as an intersection between two lines. And it's where the lines cross. It's where the roads cross. So that's your big takeaway. If you're trying to figure out, okay, so I get it, a system is like more than one line being graphed. I get that. But what's the answer? The answer is, where do the lines cross? If you can figure out where they cross, that's your answer. So, and this is just further explanation. On a graph, this is where the lines cross. So the intersection point, aka where the lines cross, that is what we're looking for. So based on that kind of reasoning, looking at that graph down below, says what is the solution to this system? Can you see how there's two lines being graphed? There's a blue one and there is a red one. What would you guys say is the solution to that particular system, Mason? Negative 2, comma 2. That's exactly right. Isn't that the intersection point right there? And Mason correctly identified the x-coordinate as negative 2 and the y-coordinate as 2. So the solution to that system is negative 2, comma 2. That would be the point that makes both lines true at the same spot. That's the answer to the system. So I'm going to ask you a question. I just want you to reply out loud together. See if you can finish my sentence. The solution to a system is where? Point of intersection, where the lines cross, where the lines intersect. Those are all good answers. I heard a bunch of good answers there. Okay, that's your big takeaway from today. So let's keep looking forward, and we'll do a couple of other examples. So let's just focus on this one right here. Number 1. Once again, I've graphed a lovely red line for you, and then a lovely blue line for you. And I've asked the question, what is the solution to this system?
No solution.
No solution. Why on earth would you say that?
Because they're parallel lines.
Say again, Ellie?
They're parallel lines.
Oh, they're parallel lines. So she says no solution. No solution. And I said why? And she said because the lines appear to be parallel. And I would say certainly they appear to be, and I think if you look at the slopes, what's the slope of the red line?
3.
Slope of the red line is definitely not 3. That's the y-intercept. Say again, Anya? I don't think so.
Which line?
The red line. What do you think, Julia? Sure, yeah. So if I count my rise and my run, it looks like I'm getting a slope of -1/2. What's the slope of the blue line?
-1/2.
It's the same thing, right? Because parallel lines do have the same slope. And if you count that off, you do get the same slope of -1/2. Because those lines are parallel, we know that parallel lines never actually do cross. They never intersect. And since we're looking for a point of intersection, and there isn't one, doesn't Ellie's answer make a lot of sense? There is no solution, because the lines never cross. Okay. How are we doing? I'm really hoping this seems logical to you, like based on just kind of the system of thinking here that you're like, oh yes, that makes sense. If it doesn't, you're raising your hand, right? And you're saying, whoa, wait a minute, I thought it should have been that or this. Okay, so the next one I'm going to let you guys do a little more exploring on your own. Number 2. And by the way, number 2 is an excellent exercise for you as far as like a quiz retry in the future, some test in your future. You're going to have to graph some lines to be able to do number 2. So if you would, please look at number 2 and see if you can graph the linear equations to figure out what the solution to the system is. And there it is right there. System of equations are usually noted with that fancy parenthesis brackety thing. You've got 2 equations. We're going to graph them both. I'll ask you again. What's the solution to a system? It's where? Intersection point where the lines intersect. So I'm feeling pretty good that no one knows what he's doing. Ellie, I think, she said something pretty good there too. The rest of you, I'm a little unsure. I'm a little nervous, but we'll see. So try it. Please try number 2. Hey guys, this is where we focus in, and this is where if I do something that disagrees with what you did, you ask. Let me know there's an issue. Okay, so the first one is y equals 2x minus 3. To me, that means the y-intercept is at -3. That's where I'm going to start. And the slope is 2, so that means I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, so on and so forth. I think that's about as far as I can go in that direction. I will then connect those with as straight of a line as I can. It's decent. And I leave it at that. So for that first line, I want you to look at what I did and let me know if you have a question.
Okay. What did you do with the +6?
Oh, okay. Hey, listen. Please be focused here. Chase just said, what did I do with the +6? And the answer is nothing. Because what I did is I graphed this line up here. I still need to graph that other line. In fact, I'm going to graph that one in red. But I have not even bothered with that line yet. There's 2 separate lines. I just graphed the top one. I did it in black. I'm going to graph the other one in red. So there is no 6 yet. Does that make sense? These are 2 separate lines. Remember, what is a system of equations?
Intersection.
No, that's the answer. That's the answer to a system. What actually, like if somebody looked at your book, your homework, or your notes, and they said, oh, you're doing systems of equations, what is that? What would you say? Say again? It's multiple linear equations. It's more than one, like 2. In this case, there's 2 of them. That makes it a system. And then, of course, Ella, what's the answer to a system?
Intersection.
Hey, there's the intersection point. Yes. So I'm going to do something with the 6 now, Chase. So the red line, the y-intercept is 6. So I'm putting that up here. And the slope is -1/4. So -1/4 would be down 1, right 4. That actually puts me right there on that other point. I will attempt to connect with a lovely straight line. Like so. And there's the graph of my other line. So when you look at it from this perspective, you can see both lines on there. We're going to be looking for the intersection point. What do you all think the intersection point is?
5,4.
4,5.
I think it's I think it's 4 comma 5 because you're going to list your x first. 4 comma 5. So you guys see how, I think you already knew this. You see how math builds on itself?
Yes.
That is, listen, that is exactly why you should be doing concept quiz retries where needed. You can't, I mean, can you see how if somebody maybe did poorly on their graphing lines concept quiz and they thought, I only made a 50 or a 0, but no big deal. Do you see how that was a brick that you needed to have in your foundation to be able to do this? So that's why you need to do concept quiz retries, so you can go back and say, man, I did pretty terrible on that first try, but I retried it, and maybe I'd retry it again, and now I have it. This is where that would be important, right? We'll keep at it. You can't, in math, expect to be poor at some concept and then have that just be okay later. You'll struggle later because of that. So let's keep at it. Okay, questions? Let me ask you a question. Please think about this. In math, did you have a question?
No,
Okay. In math, if you want to confirm that your answer really is the correct answer, what do we typically do? Plug it back in. Plug it back in. So if I wanted to check this, like let's say I felt okay about this, but maybe I was feeling a little shaky on graphing of lines, I could take my point 4 comma 5. I should be able to plug it back in and find truth or false and confirm or deny that that really is the answer. So check this out. I could try it out in the first one. Y equals 2x minus 3. I'd plug a 5 in for y and a 4 in for x and see if this is true. I'm just plugging it back in, which is what we always do when we check things in math. Just plug your solution back in. 2 times 4 is 8. And 8 minus 3, oh my goodness. It worked out in the first one, didn't it? But it must check in both for it truly to be the solution. Sophia, let me finish this real quick, then I'll get your question. So the other one is y equals negative 1/4 x plus 6. So again, I'd plug the 5 in for y and 4 in for x. So it'd be 5 equals negative 1/4 times 4 plus 6. What's negative 1/4 times 4? Negative 1, right? So 5 equals negative 1 plus 6. And what's, oh my goodness, negative 1 plus 6, that's 5. 5 equals 5. It checked in both. So since it made both equations true at the same point, we've just confirmed for certain that that is our solution. Sophia.
So couldn't you also just put in your y and then just solve it for x?
Couldn't you just plug in your y
Like just do
and solve it for x?
minus.
And if you did that in both,
Yeah.
sure, that could work. I think that's logical. For sure. Ladies, are you with me? There's so much giggly stuff going on. I'm sure it's really fun and cute and all that, but let's try to focus. I've got at least one more thing for you to think about, unless you got a question here. All right. So, along the lines of what I just showed you is a nice example of here, number 3. Number 3 basically is saying this. There's this system that you can see down below, and somebody, we'll call him Bobby, solved this system, and he got negative 2 comma 1. And your job is to answer the question, did Bobby get it right? Is negative 2 comma 1 really a solution to the system? And we need to show some work, give a reason for our answer. Because at its core, isn't the answer to this question either yes or no? Yes, it is a solution, or no, it is not. So if all you did on a question like this was write no, and you didn't have any supporting material and you just happened to be correct, you wouldn't get any points at all. I'd give you no credit because I'm thinking you just guessed, and you just happened to coin flip it, lucky day, right? Not interested in that. I'm interested in seeing your reasoning. So please show some work to give some reasoning for your answer, but let's try to answer the question, is that point a solution to the system? I'll ask it again. In math, if somebody proposes a solution, what is a great way to check to see if that solution really is the solution? Plug in. Just take that number or those numbers and plug them in and see if you get truth or see if you get false. That'll tell you all you need to know. So I'm going to check, and with these, of course, because we're looking for an intersection point, you have to check both. You can't just check one. So here's the proposed answer. I'll check the first one here. So y is 1. So I'll write 1 equals 1/2 times -2 plus 2. Right, I plug the 1 in where it goes. I plug the -2 in where it goes. And I'm going to try to simplify the right side, see what happens. What is half of -2? It's -1. So 1 equals -1 plus 2. And -1 plus 2, check it out. Feeling pretty good about this, right? Because 1 really does equal 1. This seems to indicate that, yes, this is the solution, but I've got to check both and make sure that it's true for both. So I'm going to check the other one. So this is y equals 4x plus 7. So this would be 1 equals 4 times -2 plus 7. 4 times -2 is -8. And -8 plus 7... Oh, wait a minute. Does 1 equal -1? No. So these were all false, weren't they? So I'm going to put that little slash to the equal sign. And because 1 does not equal -1, please don't pack up yet. I'm not done. Please. Come on. That's just not polite. Okay. So since that turned out to be false, then we'd have to say no. -2, 1 is not the solution. And we've answered the question. Make sure that you do actually answer the question. Don't just do some work and expect me to interpret your numbers the way that you want me to. I want you to give me a definite answer. Yes, it is. And look at my work. Or no, it's not. And look at my work. Right? Chase.
How do we turn in Desmos?
Oh, okay. Let's talk about that. How do you turn in Desmos? Say again? Yeah, so you can turn it in the exact same way you turn in any of your homework works. You can also just take a picture of it. You can also share it with me via Google Docs. Just essentially email me, your sharing. I would say those are your two best ways. So picture, dump it into Schoology, or share it via Google Docs. You guys are all good to go. Have a good day.
You don't need to take pictures of like the
I do need to see the equations.
all the equations.
So you might need to take like 3 or 4 screenshots to fit it all in there. Sasha, is that your question? I just want to see where they came from. Say one more time.
Do you want us to email you that we sent it?
No, you don't have to.